So hello, now we're getting into the next section of chapter R, which is a review chapter. It's called Functions and Models. So in this particular section, we're going to learn how to identify functions. So, one thing to remember about the definition of a function. For every input, there's only one output. For every input, it goes to only one output. That's all you get. Every input, one output. That's all you get. So, a couple other definitions. This is for a function. Another definition is domain. The domain is the input. One last definition is for the word range, and the range is the output. So, let me put an example up, and I want to know if it's going to be a function or not. So we're going to walk through it. On this side, I'm going to put the domain. On this side, I'm going to put the range. So, the domain has these numbers in it. The range has these numbers in it. And these arrows are going to tell you which input is going with which output. So, okay, now, let's take a look. The definition of a function is for every input, there's only one output. So, my first input is 5. The question is, how many outputs does it go to? Just one. So, is it a function so far? According to the definition, yes. The next input is -3. And it goes to the output of 3. According to the definition, this input should only have one output. Does it? Yes. So is it still a function? Yes. The next input is 7. And according to this arrow, it only goes to one output. So still a function. Last input is -7, goes only to one output. It is still a function. Every one of these inputs went to only one output. This is a function. Well, that's good news. Functions have different properties. But anyway, that's another chapter. Let's look at another one. It's always fun erasing whiteboards. I'm going to put the domain on this side. I'm going to put the range on this side. And in the domain we have these numbers. And in the range we have these numbers. And so, those arrows tell me which of those inputs go to which of those outputs. So, let's take a look. According to the definition, every input's only supposed to have one output if it's going to be labeled a function. So, my first input is 6. If I take a look, 6 goes to 2 different numbers. The definition says it's only supposed to go to one number if it's supposed to be a function. So, right off the bat, you can tell this is not a function. I don't have to check the other 2 at all, because if one of them fails, it's done. So this one is not a function. Done. Okay? Let's look at another problem in terms of, is it a function or not? The domain. Here's a new word for us, correspondence. and then the range. So in this case, the domain is going to be a set of iPods. The correspondence is each iPod gets a serial number. And the range, which is the output, is a alpha numeric codes. Okay, so now let's think about this. We take an iPod from the domain, an iPod, one iPod. It goes through this correspondence. It goes through this process. That's a better way of saying it. So the process is when I take this iPod, it gets a serial number. So my question to you is this. Will that iPod get more than one serial number? Will it get more than one alphanumeric code? Well, if you take a look at your own iPod, or even your cell phone, or your tablet, or whatever you have handy, you look at the back of it, you notice that it only has a single serial number. So, I take an iPod, it goes through this process of getting a serial number, out comes an alphanumeric code, it only gets one code. This one input went through this process, it only got one output. Would it be considered a function? The answer is yes, it's a function. So far so good? Wonderful. Now, we looked at sets of numbers input and output. We looked at a correspondence. We're going to look at one more item, and that other item we're going to look at is a graph. So, there's my coordinate system, and the graph I'm going to work with is this line. Now remember, every input's supposed to have only one output if this is supposed to be a function. So, when I take a look at this, my x's are the inputs, my y's are the outputs. So I can pick any x value. So I'm going to pick this one x value. And when I take this one x value and I look at its output on the graph, there's only one y value that appears to go with this x value. If I take another x value and I look at the y value on the graph for it, there's only one y value. So, is this one considered a function? Your answer is yes, this is a function. Okay? Let's take a look at one more graph. Here is my coordinate plane. And in this case, my graph is going to look something like this. Now, again, my x's are the input, my y's are the output when I graph. Always it's that way. If I take a value for x and I look at the y value that goes with it, well, I need to look at the graph. So when I look at the y value, I'm noticing that this input has a y value up here because that's what the graph tells me. But I'm noticing that it has another y value here. I'm noticing that it even has y values that go with it below it. This one input has multiple outputs. It has more than one output. So is this one considered a function? Correct. The answer is no, not a function. Hopefully hopefully that helps you a little bit more in understanding how to determine if something is a function. Have fun with homework.